Assalamu alaikum, dear students. How are you? I think all of you are well in grace of Almighty Allah. I am also fine. I am Mohammad Hiron Chaudhary, Associate Professor and Head of the Department, Statistics Department, Eden Mohila College, Dhaka. Welcome to on behalf of Eden Mohila College online class. Our today's topic is test regarding proportion, which is second year non-major course statNM 202 Principles of Statistics. Earlier I have discussed test about mean, test about variance, test about correlation, and various types of means, various types of correlation, various types of variance. Today I have shall discuss test regarding proportion. Test regarding proportion, there are three types of test regarding proportion. At first, test for a specified value of a proportion. Test for a specified value of a proportion, equality of two proportion. Equality of two proportions. Number 3, equality of several proportions test. Test for a specified value of a proportion, test for a specified value of a proportion, or single proportion. Equality of two proportion test. Number 3, equality of several proportion test. At first, test for a specified value of a proportion or single proportion. Assumption. Assumptions. The samples are drawn from Bernoulli distribution. The samples are drawn from Bernoulli distribution. Bernoulli distribution. Number 2, sample size is large. Sample size large, that is n greater or 30. The samples are drawn from Bernoulli distribution. Number 2, sample size is large. Next, hypothesis. Hypothesis. Our null hypothesis is P equal to P0, that is a specified value, alternative P not equal to P0. This is hypothesis. Next, test statistic. Test statistic. The appropriate test statistic is Z test P minus P0 root over P0 Q0 by N, which follows standard normal distribution, where Q0 equal to 1 minus P0. Since it is Bernoulli distribution, P0, P success and Q failure. And next step, as usual, comment. We know if calculated z is greater than 1.96, that is tabulated z, so we may reject A0, otherwise accepted A0. If calculated z is greater than 1.96, this is tabulated value of z. So we may reject A0, otherwise accept it. This is test for a specified value of a proportion. Next, equality of two proportions test. Equality of two proportion test. At first assumption, number one, since equality of two proportions, so two random samples are drawn from two Bernoulli distribution. Two random samples are drawn from two Bernoulli distributions. Number two, the two samples are independent. The two samples are independent. The two samples are drawn from two Bernoulli distribution. Number two, the two samples are independent. Next, hypothesis. Our null hypothesis is P1, P2 alternative P1 not equal to P2. That is, there is no significant difference between two proportions. That is, they are equal, not equal. This is our hypothesis. Test statistic. Test statistic. The appropriate test statistic is z equal to P1 minus P2 1 by P into 1 minus P 1 by N1 plus 1 by N2. This is also standard normal distribution where P1 equal to A1 by N1, P2 equal to A2 by N2, P equal to A1 plus A2, N1 plus N2. A1, A2 means number of success. Number of success. This is equality of two proportion test. Z equal to P1 minus P2 divided by root over P into 1 minus P 1 by N1 plus 1 by N2. Standard normal variate where P1 equal to A1 by N1, P2 A2 by N2. This is old estimator A1 plus A2 N1 plus N2. Next, comment. Comment. As usual, A0 is rejected if z is equal to 1.96, otherwise accepted at 5% level of significance. And next, test of equality of several proportions. Test of equality of several proportions test. At first, assumptions. K random samples, since it is several, so several let K. Several means K random samples are drawn from K Bernoulli distribution. Number 2, the samples are independent. The samples are independent. Number 2, hypothesis. Our null hypothesis is P1, P2 up to Pk. Alternative, at least two proportions are unequal. At least two proportions are unequal. Test statistic. The appropriate test statistic is chi-square test. Chi-square y square by ei minus n follows chi-square distribution with k minus 1 degrees of freedom, where ei we know y by n I equal to 1 up to k, n equal to summation ni, ei equal to n by k. Y means observed frequency. K হলো number of group. This is the statistics. And next comment. As usual, if calculated chi-square is greater than tabulated chi-square at 5% level of significance with k minus 1 degrees of freedom, A0 is rejected, otherwise accepted. Now, an example. An electric company claimed that electrical company claimed that 98% of the parts which they supply conform to specification. A sample of 400 parts was tested, selecting from the company and 45 did not meet specification. Test the company's claim. Claim at 5% level of significance. An electrical company claimed that 98% of the parts which they supplied conform to specification. A sample of 400 parts was tested, selecting from the company, and 45 did not meet specification. Test the company's claim at 5% level of significance. Solution. Here our hypothesis is P equal to P0.98, alternative P not equal to P0. Test statistic, we know Z equal to P minus 0 root over P0 by N. P equal to A by N. चलो 400 minus 45 by 400 equal to 0.887. Q0 equal to Q0 equal to 1 minus P0, 1 minus 0.98.02. So Z equal to, after putting these values, we have minus Z equal to Z 5% we know 1.96. This is tabulated value. Comment here Z is greater than 1.96, so H0 is rejected. So companies claim at 5% level of significance are not accepted. So companies claim at 5% level of significance are not accepted. So viewers, no more today. See you again next another day, inshallah. Allah Hafiz.